Hello and welcome to this episode of the Home and Energy Chats. My name is Heather Chandler and I am the owner and publisher of Green and Healthy Maine Homes. Each episode, we chat with industry experts to help you learn about healthy, efficient, and sustainable homes. And today we're going to be taking a look at foundations. Here in Maine, we traditionally build houses with basements and concrete foundation walls, but there are also many reasons to rethink this approach, including reducing and in some cases eliminating the use of concrete altogether. So we're going to be exploring those options today and learning about some Maine projects that have utilized these technologies. So I would also like to start by giving a shout out to Mike Maines of Maines Design. This episode was inspired by an article that Mike wrote several years ago, and then he updated it for our fall edition of Green and Healthy Maine Homes. So if you're interested in checking that out, you can find it on our website. So a special thank you to our sponsors, including our annual sponsor, Royal River Heat Pumps. They are a locally owned and operated company that is nationally recognized for heat pump excellence and is 100% committed to the highest standards of quality installations, service practices, and customer satisfaction. And you can learn more about them at royalriverheatpumps.com. And thank you to our season sponsor, Senecal Construction Services, offering net zero custom designs in Mid-Coast Maine. Senecal turns dream homes into reality with a team of passionate craftspeople and energy efficient quality. And you can learn more about Senecal at senecalconstruction.com. And now a little bit about us. Green and Healthy Maine Homes is dedicated to inspiring healthy, efficient, and future-ready Maine homes. In addition to these home and energy chats, we also publish the Green and Healthy Maine Homes magazine and produce the Green Home and Energy Show, which is taking place April 5th in South Portland this year. You can learn about all of these on our website, again, at greenmainehomes.com, including a business directory where you can find professionals who specialize in healthy, efficient, high-performing homes. So now it is my pleasure to introduce our panelists today. Randy Rand is Passive House Maine's training director and owner of r.haus Design Build. He manages Passive House Maine's statewide workshops, a training program offering day-long sessions statewide. He has 20 years of experience in the design, construction, and operation of many types of building styles. He received his Passive House tradesperson certification in 2022 and enjoys working and educating building owners, design professionals, builders, and code officials on ways to improve the comfort, health, and durability of our buildings. Welcome, Randy.
Thank you.
And I would also like to introduce Emerald Builders founder, Reggie Lebel, who is on a mission to make the world better one building at a time. He builds homes that represent the nexus of design, comfort, resilience, and environmental sustainability. He grew up in Harpswell, immersed in craft, and eventually settled in Bowdoin, where he now lives with his family. So welcome, Reggie.
Thank you.
Thank you both for being with us today. And a reminder, if you do have questions that were not submitted during registration, feel free to add them using the Q&A feature at the bottom of the screen, and we will do our best to get to them. And so without further ado, Randy, I am going to turn this over to you to kick us off. And as we know, typically Maine homes are built with basements and concrete foundation walls. And so can you tell us why it might be worth rethinking this convention?
Yeah. So thanks for having me. And I know the topic was foundations of the future type of thing. But what's exciting is that a lot of these things that we're talking about in the future are happening now. And I think that's pretty cool to start thinking about. Um, but let's first kind of want to touch base on what we've been seeing a little bit previously and originally here in Maine. So one of the more popular solutions for slabs and foundations is a full basement foundation. Poured concrete tends to be the go-to for everybody right now. They've come a long way over the years with the different products that and techniques and just craftsmanship and how they've been going together. But we'll talk about a lot of different advantages and disadvantages, but a lot of those things happen with no matter what foundation that we have. So, but poured concrete foundations is a pretty typical foundation here in Maine. We also use a lot of CMU block for full foundations or crawl spaces. We find a lot of those up here in the Bangor area. Was pretty common back through the 60s and whatnot. Prior to that, we had a lot of rubble stone foundations here in Maine. And my buttons aren't working. Hang on. There we go. Rubble stone foundations. So this one here you can see is just stone found in the fields when they were building the house, and it does have mortar between them. A lot of them don't. So these are our more common approaches to foundations right now. A lot of advantages and disadvantages with full foundations, which is what we typically see. You have the advantage of having additional space, right? It's down there, typically used for storage or mechanical space. But what we see a lot, and I think when we talk about main basements, the first things we think about obviously are, oh, wet, damp, dreary, those types of things. And with our soil conditions here in Maine being really wet and groundwater being really high, we tend to have a lot of water in our foundations, and managing that is one of the bigger problems. And even if we manage it, we still get a dampness to it, and those types of things. So water is enemy number one with all our foundation solutions. And you'll see as we look at some of the new solutions that we are addressing water always, right? So um, another thing that I think people think, and we've got to kind of overcome a bit, is the fact that, oh, we're building into the ground and the ground stays warm through the winter and it stays cool in the summer, and we don't need to insulate our foundations. And that is actually something that we've got to overcome. We absolutely have to insulate our foundations and thermally break our concrete to the ground. That ground, even though it does maintain a pretty consistent temperature year round, it does suck a lot of heat from our main homes and cause a lot of problems that way. So that is something that we really want to address with any foundation approach that we take, or retrofitting an existing foundation. Um, so a few other of the disadvantages obviously is excavation costs are growing, concrete costs are growing, and when we're doing full foundations, that can add substantially to the cost of our project. So we're trying to look at reducing a lot of that type of thing with new foundations that we're putting on. So and then obviously the impact of greenhouse gases from concrete in the Portland cement process. Concrete is like 8% or 10% of the carbon emissions worldwide. So it's one of the biggest things we can try to touch on and make a big impact for just our house. And make a big difference that way. So those are our typical. Oh, and then I forgot slabs. Yeah, so our standard slab, right? So we see a lot of single family ranch style homes in the state being built on slabs, just a straight up slab on grade. A lot of those, like I mentioned in the past, haven't been insulated. They're just built right on the ground. And it's very common with a lot of our affordable housing approaches. So mainly because, as we mentioned before, the cost for excavation and adding frost walls and all those things can add up pretty quickly. So So what are we doing going forward, and what are some of the new things that we're seeing? So one thing we're doing a lot now is what's called ICF foundations. So ICF are insulated concrete forms, and they go together like Legos. You can see the pile up in that upper left-hand picture there, where they are just blocks, and we just assemble them in an upward pattern. Those are hollow forms. And once you get to the top in your elevation, you can use a pump truck. You can see a concrete pump truck, and you can fill those with concrete. One thing that these do is they do reduce the amount of concrete that you actually need. They over a conventional poured foundation. So you are making a reduction. You are also getting a insulation done at the same time as your concrete, so you're not coming back and doing it in a separate layer. We like it because we can reduce the amount of tradespeople that we have on site. So this is something that we do in-house. But it does require, shoring, a lot of extra space. But as I mentioned, one thing that you can also notice with this is what our steps that we're beginning to take with waterproofing. And that idea, or that groundwater, is our public enemy number one. You can see the waterproof barrier on the outside, the stone for the foundation drains beginning to go in. So those are things that we always want to consider, and you'll see it in um, all our foundation types as a project. But in addition, there are also some ICF blocks that are using some recycled components, and those are becoming more popular too. So ICF is an industry that's growing, and the products that are becoming available are growing as well. So that's kind of cool. So now what we're hearing a lot is shallow frost protected slabs or raft slabs as an option. As I mentioned before, we've always done slabs on grade, right? The difference now is that we're really thinking about the amount of insulation that's in that. With a slab that's not insulated, it can be affected by frost and a lot of different things like that. Um, and we want to decouple it from the earth, as we've mentioned, with that sink, that it will suck that heat. And when we super insulate these slabs, it also brings that slab into the environment of the living space. So that concrete will stay warmer. It will feel cooler, but it will raise its temperature up and make it more comfortable to be on. What you're seeing here is a super insulated prep for prior to the concrete being installed. So this is all insulation being installed, and then they'll pour the concrete on this. And what will happen is in that lower left-hand corner, you can see there's like a little ridge return on that foam. And that separates the concrete from even the outdoor temperature conditions. So in this case of these slabs, the concrete is not connected to the outdoor temperature and environment. So that's pretty cool. And it really makes the efficiency of these projects much greater. So you can see that drainage below these is always a key. So adding proper stone, proper drainage, and well-draining material below it will be beneficial. And then in that concrete pour picture, you can see that they're addressing the vapor barrier also, and making sure that we are doubling down on keeping moisture from coming up from the ground and getting into our space. Not to mention potential for uh, gases like radon and not. So slabs are being done a little bit different. So that's kind of cool. Same idea we used to do. We're just doing it a little bit better now. The other idea is a slabless slab, which we are doing more of these now, and we'll get into the details of my projects later. But the idea of a slabless slab is to eliminate the concrete in the floor, but still have an on-grade type of floor assembly. So usually we are flattening the ground, and then adding insulation and doing 2 layers of plywood over it. And we'll get into some more details and dive deeper into that project so you can get understanding for that. And just the idea of eliminating all that concrete is, a huge savings when it comes to that carbon emission. Crawl spaces or short basements are good and becoming more popular. What we're seeing is that uh, we still want to have that foundation, but we want to raise that floor up and separate it from the ground. And by doing that, it allows us to have a space where we can still put some mechanicals down in a crawl space. And that crawl space floor doesn't need to have concrete. It can really be just about anything. The key to it is that we are completely encapsulating it, right? We're getting that vapor barrier in, and then that space typically also needs to have some sort of connection to your indoor environment. That way, it will not have stale air down there, and give us just some options. But it's a great way to reduce the depth of excavation and the amount of concrete that you need, and then eliminate a slab completely, but still get the flexibility to use that space for mechanical distribution. So uh, that's happening quite frequently now. Now, something a little bit more abnormal that we're starting to venture into a little bit is using helical screw piles down into the ground for foundations and lifting our floor assembly up off the ground completely and decoupling it for the most part. And what screw piles are, they're a metal post with like a screw head on it, and you can see they take like a mini excavator and they thread these down into the ground. And they provide a structural support to build upon. So you can see that picture from Mike on the left where they have framed the structure up on those metal posts. And then their floor assembly will get a full buildup of insulation to a particular R value that they're looking for that project. The project on the right is one of ours that we've done just in addition, where we just had to put in 3, but we eliminated the cost and brought the cost down for the client to be able to eliminate that concrete and that excavation. It also minimizes the impact on the ground around a property. So that's kind of cool. You can really bring that outdoor environment into and closer to the house. Um, we are another project here, and I don't think that picture got into this slide, maybe after I updated it. But we have a project here I'm following on quite regularly. It's a croft straw bale house, all built on screw piles, and they did probably 60 screw piles and built this 2,000 square foot house on top of it. So it doesn't need to be just an addition or a small house. It can be a full size home. So screw piles are becoming very popular. Um, Permanent wood foundations are kind of something that I've wanted to begin to toy with. The idea of building a house and putting wood below the ground. It's always been a scary thing, but it is coming back. It is code compliant. And what they do is they just, again, well draining material below the slab and below the structure. And they just put down plates directly on the earth with some good vapor barrier and good drainage. And we begin to, frame a conventional exterior wall with plywood and protect it on the outside with our membranes and drainage. And we can have a wood foundation. You can see that we've talked about crawl spaces and screw piles. And in this particular photo, you can see we get that daylight basement type of look. So all our foundations are going to be, dependent on site specific issues, right? Whether you've got a sloping site, you've got a flat site. So that's what helps us determine which approach that we're going to use. A lot of them just cause us to think about the way that we do it differently. But in this case, with a daylight basement and trying to eliminate the concrete, a wood foundation, full height, actually was beneficial here. So.
Fantastic overview. Thank you. I'm sure that that is eliciting even more questions. So before I do want to get into some more examples from each of you of how you have used these approaches here in Maine. But before we do, let's start with just a couple questions. One is what are the code considerations for these types of approaches that you've presented? Do they all meet code in Maine currently? Are there certain things that need to be done?
Yeah, so I mean, we often think code as a limiting factor and it being done as like this is what you have to do. It's funny that once you get it into it and you understand it, it's very flexible and it allows you to do a lot of different things. So every one of these solutions that we are doing are all, code compliant. Usually it takes, extra conversations sometimes if it's an unknown to code officials. They're not familiar with not putting concrete on the ground. Okay, so it just takes me an extra conversation with him, and this is our approach and this is what it's doing and this is how it's going to be beneficial. And they usually understand, and they're always willing to learn too. So I think those conversations are great to have.
I would agree with Randy. I think the other thing that when we've run into any type of pushback from codes at all for any of these systems, some conversations certainly can do it, and or some information from our engineers.
Yeah, I'm not going to say there's not a straightforward approach to any of it. Like, oh, let's just put in screw piles. Yeah, sure, there are spacing things you need to think about, and sizing the beams to go from pile to pile. All those things need to be considered. So it's not just straightforward and off the cuff, but yeah.
A question from Alan, who I think you touched on this a little bit already in the presentation, but he's asking, if we build houses without foundations, aren't we losing the heating and cooling effect of the ground temperature under the house? So is there anything you want to add, either of you, to that?
I think that just comes back from our passive house training and our passive house experience. What we do a lot of times with when we're going to the extent of really high performance passive house type of buildings, we are modeling our buildings and the performance and where all the heat loss goes down to every component, whether it's the screw used in the exterior siding or the way the concrete is touching the ground. And what we've been able to learn from that is that we get excessive heat loss through any connection to the ground, particularly through concrete, since it's such a poor insulator. And we're seeing like code recognize those things now, in that when you have your foundation walls and you pour a slab within it, you're required by code to separate that slab from the concrete wall with a piece of insulation, because they know that breaking that thermally will help that slab perform way better.
Anything to add to that, Reggie?
Randy nailed it. Yeah.
Okay, awesome. I would like to dive into a little bit, some more examples from projects that you've each worked on. So I'm wondering, Reggie, if you would kick us off on that and share some examples of your projects and maybe why you chose the various approaches, and if you happen to have any information on performance to date, that would be great to know too.
Sure. This is a project that we worked on with Mike Maines of Maines Design. These are all his details, but this is a project that we worked together on just in the conceptual, working of getting rid of the slab. This was for a client that a couple of houses got built for. The first house that we built worked with a raft style slab, just like what Randy had showed earlier, very similar. And we did have a concrete slab in that particular building, and it performed and went together very well. Fast forward a few years, when the client came back and said, we'd like to do another house. Mike was involved in this job, and at that point we were trying to figure out how we can pull more concrete out of any of the projects. So we went with the idea of a slabless slab, and then also this particular job, the sites were pretty conducive to a short foundation. There's relatively flat ground to work with. So we looked at some other slabless slabs. There were around. Steve Demetric out of Rhode Island had great success with some systems that they've helped develop. And with this particular job, we were looking at another option for running, our insulation layer in place of or where the slab would kind of be normally, and then eliminating the concrete. And we were looking at protecting our vapor barrier, or giving it a little bit of space. So Mike came up with the idea of using sleepers on top of the EPS foam, and then a layer of Advantech over all that. So I'm not saying one's better than the other. This was just stuff we were playing with. The details beside this, as far as the actual foundation that supports, it's a pretty straightforward assembly. This is similar to how we did the raft on the previous job. We did a lower raft of foam, and then we did a single ICF block, an extra wide ICF block that kind of created a bit of a grade beam perimeter. Mike started with a little bit of that, but found better ways to get rid of the raft below, and isolated the footing. Talking back to that last question, we want to isolate that concrete, from the ground and from outside temperatures. And then Mike created a step in the top to help also make sure that the double stud wall above covers that gap between the concrete, so everything is thermally broken.
Hey Reggie, one of the things that comes up for me quite often in discussions is that exterior foam on that stem wall, and how do you treat that? So what did you guys do to treat that in this situation? Because that usually gets left exposed when the house is done, and you can't leave that foam exposed. Normally it would be concrete above the ground, but now that we're putting foam on the outside, we need to cover that.
That's a great question. So this particular job, we didn't end up building this particular job. I'm not sure how it got treated, but the last project we've used stucco before to cover that foam. And what we've moved on to when we do have to use an exterior installation is we basically use a sheet aluminum that we can have powder coated, and that will bring that across the top and down the face, and make sure it goes below grade quite a bit. It could go all the way to the footer or to the bottom of your assembly, but at least get it down below where any potential rodents could dig or keep insects out of it. But that helps protect whatever we have that's exposed. That protects the foam. Good question. And otherwise, this particular job, the detailing for the rest of the utilities go pretty straightforward. The plumbing's going to go in that material below the EPS and stick up through, as some of the photos had shown. We've got drainage around here still, even though it's more of a slab assembly, trying to make sure that we're getting any of that groundwater away from the building. And then a key on this one also is because that's a shallow, not really a frost wall, it's a shallow amount of concrete, running insulation out away from the foundation to make sure no frost dives underneath the footing and can possibly heave or work on that wall at all. But like I said before, big credit to Mike. We had some assembly input just for how stuff would go together, but this is Mike Maine's design. That's it for this particular job. This is a job we're currently working on. We don't have I apologize, we don't have a photo of kind of the finished slabless slab. This is a home that we're doing that does have quite a bit of structural engineering in it. And we also have a site that's somewhat sloping. So after kind of going around and around, we still ended up with frost wall. So this is going to be frost wall assemblies and with a slabless slab. Everything, all the floors there's no crawl space or full basement. This gets finished off at the top of a concrete wall. The assembly that we're working with here, the frost wall, it's a footing, and then a conventional frost wall. Nothing, crazy there. One thing that we wanted to do on this particular job, there's two different wall assemblies. There's a main house, which you can kind of see in the bigger photo. Out beyond the excavators, that's an exterior I-joist wall assembly. And then where the bucket of the excavator is inside the foundation, that's a double stud wall assembly. So what we wanted to do when we still need to make sure that we frost protect our foundations, vertically. And conventionally, we do that with either a layer of vertical foam. Working, not like what Randy was saying, the ICF takes care of that. But if we're working with a conventional concrete wall, we're going to either put up a piece of foam or mineral wool, generally speaking. What we wanted to do on this one is see if we can get away from either of those products and kind of keep things a bit streamlined. So the product that's being used here is called foam glass. This particular brand is called Glavel. So this is an aerated glass aggregate that has an R value. And what we're doing on the photo on the left is we're starting at the top of the footing or right beside the footing with a width of Glavel, and the inside of that particular square is filled with coarse sand, and everything gets compacted in lifts. And what we're trying to do is build somewhat of a perimeter column of Glavel to do our frost protection. And then if you look at the photo with the two machines in it, for this particular job, we wanted about 18 inches of Glavel across the flat. So once we get to that height, the sand layer stops. The Glavel on the perimeter has come up around the perimeter of the building, and then we fill the rest of it with Glavel, compacting it, in lifts. So this product, it works very well. And then as we get closer to the top, the photo on the left shows we've got our plumbing coming up through, and then we also have, this is our radon loop that's being established here in the pipe that lays on the ground. And then once that radon layer is done, the Glavel comes up even further, covering that else. So the Glavel can act is a good material to use, for air to move through for our radon layer. At the tip top of this assembly, of the Glavel, we put a layer of geotextile fabric, and then we did a shim layer, which is the photo that has the lighter colored material. That's a layer of 3/8 pea stone that goes from a depth of 0 to about 1 inch to 1.5 inches, depending on, the Glavel is a larger aggregate, so it's hard to get it perfect. So that's what we've got going on there. And then above that, we have a 15 mil vapor barrier that is our vapor barrier. It's also the start of our air barrier assembly. That goes across the flat, turns up the little tiny bit of wall we have, and gets sealed or taped to our capillary break that's on the top of the foundation there. This particular slabless slab assembly, we're going to end up doing probably a sleeper layer over the top of the vapor barrier with a double layer of subfloor sheet goods. So that's gonna, once we get to the top of that, we're at the top of our mud sill, and everything from there goes up pretty conventionally. So the big key around some of this stuff, although you can see in both of these photos, as the plumbing comes up through, our plumber always just this was all prepped for if it was a slab. We don't need that wrap of kind of sill seal as a as a space breaker for the slab. So that stuff will come off, and any penetrations that do come up through that vapor barrier get sealed to that 15 mil poly very well, with gasketing and a lot of tape. So that one's coming, but we're otherwise for this particular job, we did have quite a bit of shear wall detailing in the engineering side, and that's one of the swaying factors that kept us, along with the slope of the site, that kept us, frost walls assembly for needing to tie the shear walls to. That's not saying that you have to, but for this particular build, this is where we landed. So we were able to pull all the interior slabs out. So we're pretty happy with that. That's about it.
Awesome. Thank you, Reggie. That was really helpful. Randy, do you want to share a few of your projects too? And just want to do a time check to be sure we also have time for Q&A. So maybe just a few quick ones.
Sure. We're doing a lot of slabless slab stuff. So this is our current project with the slabless slab. Very similar to what Reggie had done with his concrete stem walls all the way around. We're backfilling with gravel as well. Gravel is has insulating properties. It's only, I think, half per inch or something like that. So it does take up quite a bit of space to get there. What we did was infill our entire foundation. And then before we started doing much beyond that with our slab, we actually assembled our building around it. That way we put our prep all within the outside of the weather conditions, because you'll see right now we're on top of that gravel, leveling it like Reggie had done. And then we put our vapor barrier in, was the next step in our case. And as soon as we put that vapor barrier in, it becomes a swimming pool. So we wanted to make sure we kept any potential rain out of that assembly. And same as Reggie mentioned, we've taped that vapor barrier off, sealed it to all the plumbing penetrations, which are below. And we put that vapor barrier down because we're only doing one layer of insulation in this property. And then we're doing the 2 layers of plywood. And with our plywood, if we go to glue and screw them together, the 2 layers, the fasteners that go through are longer than the thickness, and you would puncture your vapor barrier. So understanding the order of assembly in any of these projects is pretty critical. And just walking through and prepping ahead of time, can save you a lot of headaches down the road if there's ever any issues. So that's our current project. And then also wanted to kind of touch on some of our pre-questions came in on existing foundations and solving for existing issues. So I wanted to share this renovation where we actually excavated the entire exterior of the foundation. And you can see what we found once we get down to that black pipe. That is supposed to be what's draining water from our foundation, right? And preventing it from getting in. And that is clogged. So it was really our best solution to addressing this foundation. And to put it back, we elected to use comfort board, so a rock wool, mineral wool insulation on the exterior of the foundation. The gray sheets that are covering the insulation in the next photos is a drainage plane to help reduce water pressure, and drain water down to the underdrain. And then you can see the underdrain with the underlayment, with the filter fabric getting ready to go in. One important thing as you're talking and getting into foundation projects is make sure we are completely wrapping your stone underdrain around your or else you will get that silting condition where you're filling your pipes with debris. So Some contractors want to put filter fabric just below, some of it want to put it just above. Completely wrap your stone in your under drain. One of the most important things. I usually in one corner or another also, you can see the pipe in that upper right hand picture has a white pipe that's going vertical. We usually provide clean outs into our under drains also. That way it gives us the protection to be able to address that. And then again, we went to a slabless slab on the interior of this retrofit. We had to take out the existing concrete. You can see in that picture to the left that water had gotten in and was causing failure in this concrete slab over time, mainly because the drainage was an issue. There was no interior under drains. Around this. So we were able to add new stone, new drainage, get rid of our radon, and then reassemble in that same approach with the slabless slab. In this case, we did not use a gravel, so we had to do additional insulation. And we did two layers of 3-inch rock wool. And you notice we put our vapor barrier between them before we did the new plywood, 2 layers of plywood over it. So just a retrofit project and a new project with slabs of slabs. They seem to be a growing trend. One thing I'd like to see, these slabs going to the point where we can do them as slabs only and get rid of those frost walls and, use a product like a CLT, a cross-laminated timber panel as a floor assembly over the insulation. So I think that's the direction we're going, and pretty excited to see something like that happen.
Great, thank you. And thanks for including the retrofit project. We did have a lot of questions on that. I did want to just put a plug in too. I know you mentioned the Glavel, which is out of Vermont. There's also a Maine company, Jeunesse, that's distributing a recycled glass product now as well. So kind of nice to have that here in state. So let's go ahead and transition to questions that have come in from our viewers. First one is a lot of people wondering about the costs of these alternative foundation approaches compared to a traditional approach. And in particular, one listener wanted to know how this affects building affordable housing. So could either of you comment on the cost comparison to traditional approaches?
Yeah, sure. What I'm seeing is one, concrete costs are going sky high right now. They appear to be, and so does site excavation. So and backfill gravel. So if we can eliminate most of that, that is a serious cost savings. And then or substituting them with other products. So even in the case where we're building a concrete frost wall, that cost is the same no matter which direction we went. And by eliminating the concrete slab, it was essentially a cost neutral decision. Once we started adding gravel instead of extra inches of foam insulation or something, or rock wool below the slab, that's where we started to see some cost increase. But like I said, with the cost of gravel right now, it's becoming much closer. So in those cases, I'd say that that project's pretty much a wash. Anything when you're going to a screw pile, in my opinion, is very cost competitive and can be very affordable. You're not doing any excavation, you're not bringing any concrete slab, so those work well. You do have to beef up your floor assembly, but those types of projects are definitely a cost savings. Any other thoughts there, Reggie?
I would say the same thing that we're seeing with like the slabless assemblies are pretty much a wash. Once you pull the concrete out and you put in a floor. The other place if you look at a little further into the project of how what you're looking for finishes. If a person really wants a polished concrete slab, then that might be your answer. But if you're looking at tile, if you're looking at wood floors, stuff that's going to want to be on or any particular finishes that want to be on like a wooden section of floor, then the slabless slab I think starts to pull a little further ahead. I would say the same. What we found is the same as with the gravel. I feel like for us, if we're gonna do 8 to 12 inches of crushed stone for our radon layer, we do get to pull that out of the assembly. We're pulling out um, a foam board, for our vertical and for our horizontal, or a mineral, whatever you're pulling out, that and then the labor associated from us to do those installs. So I mean, we're feeding the gravel back in. We found the same thing what Randy said. It's by the time the dust settles, the gravel might push it a little bit up, but we're also seeing the same thing, that gravel and trucking and excavation costs are going up. So
lots
the
of
other thing,
without added cost.
the other thing that it's hard to put a value to, though, is comfort when it comes to these slabless slabs and not being on a concrete floor all the time. They are softer, they are better on your body, and ultimately, I feel like they make it more comfortable to be in for a home.
yeah.
Great. You started talking about the helical piers, and we've actually had quite a few questions on that, so I thought it was a good segue into that. I'll group them all together since you'll be talking about them. Where are screw pile foundations most practical to use, and how do you protect helical screws from corrosion? And then another listener asking, how do you deal with water and sanitary with pier foundations?
Yeah, great questions. I mean, we've seen, over the years that people have been putting steel in the ground and trying to support porches and those types of things, and they've never been successful over time because of the corrosion and whatnot. The approaches that they're using now, the steels that they're using now are all galvanized. So they're better quality materials, and they are hollow in the middle with the idea that they won't hold water and won't be susceptible to that constantly. The other question was where they're better used and what. So obviously, if you've got really rocky or shallow depth soil conditions, it becomes more difficult. I've done a couple major decks where it's been pretty rocky. It does make it more of a challenge. They can still do it. So like a lot of camps along the shorelines of, lakes in Maine are trying to do them, and they run into rocks. They can still do them, get around them. They're able to, I don't want to say bend them, but manipulate them in a way that they can get around and push that stuff out of the way for the most part. And what they usually do, if you've got clean soil and the screw will just keep threading and threading and threading, their goal with the screw pile is to thread it until it reaches a certain torque and it torques out. And that's when they know it has the bearing strength that they're looking for. So that's essentially how they kind of work.
Anything to add to that, Reggie?
I would no. I mean, I would say for us, we the jobs where we've looked at trying to employ them, a lot of the stuff we build ends up being coastal, and luck of the draw, ledge ends up being very close a lot of time for us. Not every time, but like the job that we were in the process of, bedrock was very close, and actually coming out of the ground in some places. So we don't get to employ them as much as we certainly would like to, I would say. But I would say, yeah, I agree with everything that Randy said.
One other question on piers. Ernest is asking, can a home be built upon or over an existing basement using helical piers?
So helical piers are actually being used quite a bit to restructure existing concrete foundations that are failing. So like people have to excavate a concrete foundation and then drive piles and then bolt it to the concrete to be able to save that foundation. So you can work in and around existing structures pretty well. you can't get into the middle of the spaces typically, but if you've got a slab or anything like that, they can definitely either cut into them and drive them and reshore things. There are a lot of options. And sometimes they can get smaller equipment to drive to screw these into the ground to be able to get into like basements or things like that. The other thing you mentioned, Heather, before was the how do we get our water and sewer when we've lifted houses off the ground, whether it's helical piles or, on the coast now we're building on piers and getting things up above the floodplain. You really try to centralize that stuff where your sewer and your water comes in, and you do make a minimized connection to the ground somehow, and connect that into um, ideally somehow, have it be connected to the conditioned space so that, you don't have to deal with the freeze and thaw type of thing. But normally you'll cluster it in the center of the house or to the side, side or the other, and you will build walls around that stuff down to the ground and meet the ground. So.
Bill is asking, how is humidity controlled in encapsulated or conditioned crawl spaces?
So as soon as we encapsulate and enclose it, we're really helping our humidity because most of it in those cases is coming from the ground. So by getting that step taken care of, we are drastically reducing the amount of moisture in our crawl spaces, basements, or whatever it is. So encapsulating, step one, most important. Then depending on the space and the house, usually you do want to connect that into the conditioned space somehow, and circulate air through it. So a lot of times we've seen in a retrofit, we've just had to put a grill into the floor in a couple rooms, and that has been enough to, keep it from, being outside of a normal, uncomfortable situation. So you can also ventilate it, but you don't want to bring that ventilation to the outdoors and introduce outdoor air into a crawl space.
We do have a couple questions about heated slabs or pairing slab foundations with heated floors. Can either of you speak about considerations for these approaches?
I would say for us, a lot of times for the buildings that we're generally doing, for the heat loads or the demands, for the energy demands on the building are going to be so low that bringing in like a radiant style slab, or if there's a slab and running radiant in that, it's the feel, how it works, and the feel of it is going to be very different than what people are conventionally used to. The heating demand on a lot of these houses is so low that although it is a viable way to heat, it's not necessarily going to feel warm underfoot per se, like a lot of us would be used to feeling. It's going to be doing its job, but it's the requirement for the temperature of that water or the liquid running through the pipes through the slab is going to be quite low, and it's so a lot of times what we do, we don't end up running radiant systems. We end up moving on to, mostly for us it'd be heat pumps or other alternatives.
Yeah, you can introduce, depending, obviously, like, Reggie and I are both pretty focused on that passive house approach where we're reducing our heating load so much that the interior spaces maintain a constant temperature no matter where you are in the space, and all the surfaces are within just a couple degrees of each other, whether it's the floor, the wall, the ceiling, or the countertops or the tile or whatever, tend to be maintained very consistent throughout the house. But if we're dealing with a house that is more conventionally built, say just a code built house, and you do need that additional heating load, any of these approaches can still accommodate a radiant floor idea or a technique. So.
Several listeners are interested in alternative cements with lower carbon emissions. We also received a question about using alternative cements with ICFs, which are insulated concrete forms, for anyone who's not familiar with that. So what are your experience working with these alternative cements with lower carbon emissions? Which really has to do with the aggregate in the cement. Is that correct?
Binding agent typically. So the Portland, they're replacing some of the Portland with a different additive, right? We haven't done much of it. We're usually such a small load of it that we're not asking for it from our concrete supplier at this point. I don't know if they're doing a lot of it themselves. It's probably a conversation that I need to have with them to understand what is available here in our local area and whether they're doing it or not. But I know things like fly ash and some just different chemicals are being used in lieu of it, but we haven't dealt with it specifically here yet.
Reggie, any experience?
Same as Randy, really. We don't. Yeah, we don't. One thing we did look into would be, I believe it's CO2 entrainment. Quite a while ago. I haven't. We haven't seen it yet, but that doesn't mean it's not out there. Yeah, our experience is basically exactly the same as Randy. We should be more. I mean, I should be more on top of it. But when last we looked into like the CO2 entrainment, it's technology that's available, but we couldn't find it locally the last time we looked for it. But it's been a little while, so there's certainly could be some options out there.
And I'm coming from a more remote part of Maine up here, and I'm sure Portland has a different availability of different products than we're used to dealing with. So, yeah, definitely ask.
Yeah.
I think we have time for just one more question, and we have so many more awesome questions here. So we have received several questions about site conditions affecting the viability of some of these different approaches. Katrina asks, how does the slope of your lot affect these techniques? You also touched on bedrock earlier, but do certain methods minimize blasting and cost for folks with a lot of ledge?
Yeah, I think site always determines kind of like our approach or our thought of how we're going to do our foundation. And I kind of mentioned that earlier. If you've got a drastically sloping site and that's what you choose, and that's where you need to build, I think most of these methods can come into play. They just need to be, addressed for that situation. So if you're doing screw piles and the backside of the house drops an extra 8 feet, that means the pile will come up out of the ground, and then you need a bigger post from that pile up to your structure, and you can slope it that way. If you're doing if you want to do a slabless slab on a slope, that may be more difficult because now you're making on that low side, you're putting in an 8 foot tall concrete wall to support a slab on grade. At that point, it may make sense that you do a full foundation, and hence, in the case, a wood foundation on that project I showed earlier. So site conditions obviously affect how the house is going to sit on it and what foundation you use, but I think most of them can be used. They just, done in a slightly different way or do what makes sense for that site.
Yeah, I agreed. I think just tailoring, looking at any, I think if you have the luxury of starting from scratch, then looking at the assembly or the assemblies that you really want to use, and try to tailor that in the design process, if you're working with the designer, or just as you're thinking about the project, just tailoring it to where you want to build and seeing what's viable. I same thing with what Randy said, but I think there's certain things, like if you are going to have a slab, for instance, whether it was a basement slab or if it was a slab on grade, you can look at pulling the slab out. I think is a relatively easy lever to pull, depending with some structural stuff and all that. But and as you get to the other foundation approaches, yeah, I would say trying to tailor them, to the site the best you can is, or place your house if you can with the stuff you want to do in mind, with the assembly you want to do in mind.
Yeah.
But no matter what site you have, no matter how slope it is, how flat it is, deal with the water around the building, deal with the water down where you're going to, and deal with the water coming off your roof and hitting your foundation.
The great final comment.
Agreed.
Thank you. Thank you both for being with us today. You are really doing some cutting edge work, and we're so lucky to have you here in Maine and so lucky to have you both join us today for the Home and Energy Chat. So thank you very much. Thank you also to our sponsors, Royal River Heat Pumps and Senecal Construction Services, and our webinar producer, Rain Rayner, who's been handling everything behind the scenes. And as we mentioned earlier, you can learn more about some of these foundation approaches in the article that Mike Maines wrote, which is posted at greenmainehomes.com. I think if you just search foundations, it'll come right up. You can learn about upcoming home and energy chat sessions there. You can also follow us on Instagram, Facebook, LinkedIn, sign up for our newsletter, all of that. So mark your calendars for January 22nd is our next webinar. We're going to be hearing from Efficiency Maine about the newly expanded Green Bank and other state and federal tax incentives. Exciting news for anyone interested in planning energy upgrades and efficiency improvements. And also, of course, we mentioned our home show April 5th in South Portland.